1091 shortest path in binary matrix. Given an m by n binary matrix grid, return the length of the shortest clear path in the matrix. If there is no clear path, return -1. So what is a clear path? A clear path in a binary matrix is a path from top left corner, index 0, 0, to the bottom right corner, index n-1, n-1. All the visited cells of the path are 0. All the adjacent cells of the path are 8 directionally connected. So what is that? So we can go top, left, right, bottom, and for the 4 corners direction that we can take. As you can see, like this is one of the corner directions. So in this example, what we can see is this is the grid that I have, and this is a 1 and 1 are considered obstacles, so the only direction that we can take is from here to here, so it's going to be 2. Why 2? Because it says the length of a clear path is the number of visited cells of this path. So if I have one cell here and another cell here, so it's going to be 2 cells, so the length of this path is going to be 2. Let's see another example. In this example, I can take from here to this cell and then this cell and down, so it's going to be 4. And for this one, we are going to return -1. Why don't we need to even think about it? Because there's first cell, which is at index 0, 0, it's an obstacle. So it means if we at the first cell, which is at index 0 and 0, or n-1 and n-1, if we have anything other than 0, we are going to return -1 right away. So when we are talking about finding the shortest path, especially for undirected and unweighted graph, we are talking about like the best solution to approach this kind of problem is BFS, traversal. So and the reason that we use BFS is we start from the source vertex, we go through the minimum edges, and we get to the like final end vertex. So let's write down a few things so we have it in mind and we don't forget it while we are coding. So this is recommended to do that. First thing that we need to remember is like we are going to use BFS, and the other thing is like we are going to save the scene cells, right? The scene cells, their indices somewhere, right? Indices. We are going to save them somewhere, and I'm going to use a set. The reason that I'm going to use a set because the lookup time in a set is going to be constant. Another thing that I'm going to use for BFS, we are going to use Q, and I'm going to use a deck from collections, right? And which I'm going to put the like row and column and the distance, I'm going to store it here. And another thing that we need to know that if we are at index I and J, and I and J like let's say 0, 0, or it's n-1 and n-1, which means the last indices, and if they are not equal to 0, we are going to return -1. This is one thing that to remember. Another thing is while we are traversing during the traversal of this graph, if we see 1, we are going to avoid it, we are going to skip it, we are going to avoid it, right? These are the things that we need to keep in mind. So let's start with the first special case that we have, which is item 4. If the we need to know the length of the grid, the maximum point that we need to get, right? So I'm going to say n is equal to the length of the grid, and m is going to be equal to the length of the grid at index 0. So n is the row, like maximum row that we have, and this is the maximum column that we are going to get, right? So I'm going to say if grid at index 0 and 0, if it is not equal to 0, or if grid at index n and m which is the end, it's not equal to 0, we are going to return -1 right away. So that's it. It's problem solved. There is nothing to do. And this is a special case. Then what I'm going to do, I'm going to start like from the index 0, 0, and I start traversing the grid and this graph all the way down. So as I said, I'm going to use Q and I'm going to use deck from collections, and also I'm going to have a scene set that I'm going to store the visited sets. So after doing this if condition, we know we have 0 at index 0 and 0. So we know this cell is 0, 0, and we can consider it seen and visited. But we need to store it somewhere. So I'm going to add it here. Also, I'm going to add it to the deck as well. The reason that I'm doing that is I'm going to pop that out later because I'm going to use it for the next move. So I'm going to say at index 0, 0, and I'm going to consider a distance here as well. So what I'm going to store in the deck is going to be the row, the column, and the distance. So why distance is 1? Because we said every single cell that is visited, we are going to consider like we are going to add 1. So the path that we are going to, the length of the path that we are going to return is the number of visited cells. So because we have visited cell 0, 0, I'm going to consider distance 1. So then I'm going to say while Q, as long as the queue is not empty, it means there is a cell that needs to be visited. So I'm going to say while queue. Now I'm going to pop the items from the queue. I have a row, I have the column, and I have the distance. I'm going to say from this queue, I'm going to pop from left. What is that? It is first in, first out. So we are going to pop from the left because we are going to append from the end, right? So I'm going to pop from the left, and then I'm going to check this row and this column are not equal to the maximum point that we need to get. And if they are equal, it means we are at the end of the graph. So there is nothing that we need to do. So I'm going to say if R that I have is equal to N and C that I have is equal to M, then I'm going to return the distance, which means I have visited all the cells and I can return the distance. Otherwise, what I'm going to do, I'm going to go in 8 directions. So now what should we do? We are going to in 8 directions, and for doing that, there are a couple of ways to do that. I can have a like for loop that I create the directions there, or I can use a function to do that. I'm going to do it using a for loop. So we keep it as one function, but you can have a we can have a direction as well. So I am going to say, what I'm going to say is I think it's nicer to have a separate function. Let's have a separate function. So I'm going to say directions that I can take is going to be equal directions. Sorry. So I'm going to have a function here. Let's have a function here. I'm going to say for direction, I am going to get an I and J, and I'm going to return a list. And what do I have in the list? I'm going to have all the 8 directions. Let's start from the top, bottom, left, and right. I'm going to say I plus 1 and J, which is going to be the bottom, and then I minus 1 and J, which is going to be the top, and then I'm going to say I and J plus, which is going to be the right, and I'm going to say I and J minus, which is going to be the left. Now I need to cover the corners, so I'm going to say I minus 1, which is going to be the like top row, and I'm going to say J minus 1, the left corner, and I'm going to say I minus 1, the top row, and j plus 1 is going to be the top right corner. And then I'm going to say I plus 1, which is bottom, and j minus 1, and I plus 1, and j plus 1. So let's see. So this is what is happening, right? This is what we are going to have for the directions. This is going to, so I'm going to call the direction, and I'm going to call it for the row and column that I have popped out of the queue, the row and the column. So I get all the directions, so I have all directions. So I need to have a for loop to iterate over them. So I'm going to say for direction in directions, which is a list. Now what I'm going to do, I'm going to see if the direction that I have is in the scene, and if it is in the scene, I'm not going to do anything. I'm going to say if the direction that is given is in scene, I'm going to just continue, do nothing. And also I'm going to say I and j are equal to direction. So I'm going to say if the I that I have is smaller than 0, or j that I have is smaller than 0, I'm checking if it is within range, or I that I have is bigger than or equal to n, or j that I have is bigger than or equal to m, and or we need to consider the obstacle that we talked about in item 5, right? While we are doing the traversal, if we see an obstacle, I'm gonna like jump, like skip it. So I'm going to say if the grid at index I and j, if it is not equal to 0, which means it's not a clear path, I'm going to continue again. And otherwise, I am going to add this item, this direction to the this direction to the set. I'm going to say the direction. You could write I and j as well, right? See? And then I'm going to add this to the queue as well, the queue dot append. And what I'm going to do, I'm going to add I'm going to add j, and for distance, I'm going to add 1, because it means if we have gotten here, it means it is a clear path that we are here. So I'm going to add that to the list here, right? And then what I'm going to do, I am going to do one more thing here. While I'm doing this, this is going to be n minus 1, and this is going to be n minus 1. This was my bad, because if it is n minus 1 and m minus 1, it is equal, or I can add minus 1 here, so it makes everything, I think it's gonna make everything easier. Okay, so instead of that, I'm gonna do this, right? Because we had the n and m here, and we had them here as well, so it's better to, or if I do that, then it's cause a problem here. So I'm going to say if it is bigger than. I hope you're not confused. What I'm doing is I'm setting up the condition for the last cell. And what is happening here, I can leave this as it is, right? I can just leave it as it is. And let me do that so it doesn't cause confusion. Okay, so what is happening here, I'm gonna leave it as it is. This is the length that I have, right? So, but I need to check these conditions properly. I need to check the last cell, so it's going to be n minus 1, m minus 1, and also here I'm checking the last cell, so it should be n minus 1, m minus 1. But for this one, I'm saying if it is equal or bigger than, then it's going to be fine. So, and what I'm going to do, I'm going to say if these are not the correct condition, I'm going to return minus 1 here. So the time complexity for this is going to be linear, and the space complexity is linear, as well as we are using the queue, we are using the set, and we are iterating over the grid once to find the shortest path. So undetermined string literature. Okay, so I think I have made a mistake here somewhere. It says, where did I make a mistake? It says here, right? This is line 11 here. There we go. And it says an argument and 3 were given. My bad here as well. So we should be very careful about this kind of errors that can cause our code not working. There we go. And thank you.